Good morning, everyone, and I'm here to talk about building blocks in general, and then I'll talk about why inference we see as the next building block and the things you can do around model choice and just choice within AWS in general. But I'm not going to talk the entire time about Gen AI because I wanted to talk about some of the other things that I believe are really important for every startup to be thinking about on their journey to becoming a unicorn. So the first service I just want to give a bit of a refresher on for those who aren't intimately familiar with, which was Amazon Aurora. It was mentioned in the last presentation. Now, what we typically see for startups when they get started, they build their first workload, they often just build a database hosted on an EC2 instance. Maybe they're using RDS or a database as a service application. And then as they scale, they come across one of two main problems. First of all, they have to scale up their infrastructure, and then they've provisioned for peak, and then they have a cost optimization problem. So this is where the diagram on the left there, Aurora Serverless, is really a good way to help solve for that because it can scale up and down vertically the right infrastructure that you need for your database needs at that time, as well as scaling your storage in and out. So serverless is quite a popular solution that we see for cost optimization. The next diagram on the right is Aurora Limitless. Now, whilst you can scale up and down vertically your database instances, one of the biggest problems around relational databases at scale is scaling the writer instance. Because traditionally, to do that, you would have to shard your database into multiple different instances and then change your application logic to be able to route to the right shard. Whereas what Aurora Limitless does is it manages that whole process for you, sending the transactions through to the distributed transaction router and then up to the appropriate shard. So again, as you're looking up to scale to thousands, tens of thousands, millions of users, and you have relational database needs, I would encourage you to have a look at that service, which is why it is actually the fastest growing service in AWS history. And over 95% of our largest customers, our top 1,000 listed here, use Aurora. The next thing I want to talk about is private link. So if you're building a SaaS solution, which many startups are, you might be talking to your customers who say, I want to consume your product, but I don't want my data to traverse the internet. So traditional ways of doing that might be creating a VPN between your SaaS environment and your customer's environment. But creating multiple VPNs becomes very complicated. You need to make sure that you have no overlapping IP ranges. But what Private Link does is allows you to provision a network interface into your customer's account and then route traffic privately over the AWS backbone. So you can help solve that challenge that your enterprise customers might be asking you about, which is that private data of that not traversing the internet. And for this reason, we see plenty of successful software tech companies, partners of ours, some of which are out in the hall today, so you can talk to them about how they use Private Link, who have built around this particular piece of technology to solve that particular problem and mitigate the challenges of selling to enterprises. One other pattern that I hear and I see a lot that startups ask me about is my customers are saying they want me to deploy my software into their environment. They want control over it, but I'm a SaaS company. Well, how do I think about that? Well, there's a couple of different patterns that you can leverage there, what we call SaaS Anywhere. So if you think about you being the SaaS provider on the top and then the remote tenant being your customer, one thing you could do is just deploy the data layer into your customer's account. Give them control over the data store, the database, where that important data is sitting, so that they can say to their regulator or their compliance team that I know who has access to my data and I can provision that as needed. Another method would be to distribute your application so that you have part of your application running in your SaaS environment, part of the application and the data store running in the customer's environment. And then the third one would be to just be a control plane, to just be the control plane that provisions, manages, and updates the software that you provide into your customer's account. So the more you move to the right, the more complicated that is to provide the service. So you probably will also want to be thinking about how you're pricing each of these different tiers based off the complexity to build, manage, and deploy that software for your customers. The third building block I wanted to talk about is Nitro Hypervisor, which is something that anyone using AWS is using, whether or not you realize it or not. And Nitro is a really important innovation for us because it allowed us to create a very secure, hardened, and isolated environment for all of the virtual machines that run on the platform by separating the hypervisor into a special Nitro card that runs within our droplets or the hosts that run instances. As a result of being able to separate that and create additional hardening, we do things like ensure that your instances don't suffer from data residue issues. So what I mean by that is if you're, say, training a Gen AI model on a GPU, data is sitting within your cache, and then you stop that instance and it goes back into the pool for other customers to spin up and start their own training. What Nitro does is it zeroes out all of the data on that instance, including clearing out the GPU caches, which can take up to 15 minutes to do. That's not something that you get by default with other hypervisors. So again, we're always thinking of security first. Additional benefits of Nitro is it can mitigate side channel attacks, where people running on the same infrastructure, even in a different virtual machine, can have an ability to understand your workload just by the characteristics. It protects against firmware vulnerabilities and resource contention, hypervisor exploits, etc. One other benefit is that you can even create these additional constrained environments within your instance called Nitro enclaves for those highly sensitive workloads, including model training, including fintech and healthcare. Moving on to the Gen AI part, we think about inference as a building block, similar to those other building blocks that I spoke about, and we see inference being a core component of most, if not all, applications going forward. With Bedrock, the way that we designed that was to give you model choice to the leading providers out there. We've heard from Anthropic. We've got a range of other model providers, Meta, Stability, Luma, including some of the models that Amazon has released ourselves, such as such as the video generation models like Real. And I'm going to give you a demo here based off something that we have a demo outside. All right, so that's Nova Real in action. That's my face that's been merged into a bunch of videos, and many of them were generated from a Korean audience, so you can see why it didn't match up 100% of the time. But what I want to do now is talk through how that works, how this demo came to be. So first of all, what you do for this demo, you take a photo, upload it through recognition to recognize the face and crop it, then enter a prompt into Nova Real to create one or more videos like the cooking, the surfing, the Squid Games videos you just saw, generate the videos, then pass them back through to SageMaker to then synthesize the face with the video and create me looking like a stupid person doing a bunch of the things that I was doing. Return the videos. For a more common pattern, this is what we see most people who are building for adding a LLM to an existing application. What the workflow looks like: as a user, you will send a prompt to a generative AI application. It will then typically go and query a data source, a vector data source, or knowledge bases to get extra context about proprietary information through to that query. Pass that back to then send to the API layer, send to Bedrock with a query that has context about your business, which then returns that query in a generated response. And that's quite useful for Q&A. It's quite useful for getting answers about certain workflows or patterns. But what we see is this alone is not enough. So we see customers who've got knowledge workers who are stretched, and just having access to chat to an LLM doesn't give them enough to automate more of their workflows. LLMs are powerful, but they can't take actions. Integration of databases and data sources is quite challenging, as well as building the agents for multiple languages. So I'm going to give you one example here of a customer in ANZ, which is in Australia, who built a agentic architecture for credit decisioning using Bedrock and LangGraph. So what they've done is they've built two different types of agents. On the left, there's a data science agent. Now, this data science agent does what a data scientist would do, and it's helping with building and training and deploying AI models. And it uses Claude Sonnet under the hood to go and help with a lot of those tasks. Then there is a portfolio agent on the right, which helps translate natural language through to SQL to be able to query the different data sources which are brought together in this architecture to help a portfolio manager making a decision about a credit score based off the AI model. So what you've got here in this architecture is an orchestrator which helps route the query to the right model, and then the right model going and doing the thing to help come up with credit decisioning results. And again, at the bottom, we've got all these different models that are used for the right reason. Claude Sonnet for the Q&A, Haiku to do the orchestration at the top, as well as some of the self-correcting capabilities, and then Titan to do the embeddings into the vector database for semantic search. Not everyone can use the models that we have on Bedrock serverless, and they might need to build something custom for themselves or do some continued pre-training. And so we see some patterns emerging as well where customers are deploying out their models to SageMaker or hosting on container management services like ECS or EKS. Now, the good thing is, if you want to do that, it's pretty straightforward because all you're doing is just subbing out Bedrock for either SageMaker or a container management process, but otherwise the workflow is the same. And the other benefit that you get from doing this is that you can then have choice around the underlying infrastructure that you use to run that model. So it's not just about model choice, it's about infrastructure choice to help with things like cost optimization. We've got examples such as a music startup that was able to move 24 of their H100 GPUs to AWS Trainium to get for their PyTorch model, which helped them with a 50% increase in price performance. There was an AI fashion startup in India that did a similar thing and moved their workloads from the A100s through to AWS Inference and got a 200% increase or up to 600% increase based on some of the other chips that they were testing. Here's another example of a customer who's done just this. So in Vietnam, there's a customer called ArtMind, and they have an application called Apero Genius. And what this does is it helps create official art, like original art, an AI art generator, using your mobile phone. They had existing investments with a bunch of A100 chips, and they wanted to scale. So we spoke to them about, don't just replicate what you've built previously. Let's see how we can be more cost efficient with how you run that on AWS. So we can use different size models for Stable Diffusion for the image generation, and then we'll use an app manager to route the request to the right instance. And you can see on the right-hand side here, we have a P4DE managed node group for the larger model instantiation, matching what they had already. But we've also created a cluster of GCC spot instances. So they can get really good price performance of a spot managed cluster, which is much cheaper than on-demand for the smaller Stable Diffusion use cases to help save them a lot of money as they were scaling. I'll give you one more cost optimization example, which I think is a really powerful one. There is a company in Australia who were a startup, but they've grown to no longer be considered a startup. And they were looking to do a Stable Diffusion training run, and they had a budget of $10 million to do that because they had budgeted that they thought that they needed 64 P5 instances within a cluster for their training workload. So they came to us and said, can we have 64 P5 instances, please? What we said to them was, why don't we have a look at what you're doing and see if there's a way to optimize your training environment to get you better bang for your buck. So we had an SA work with them, and what they did is, first of all, they looked at the way that they were doing their model training, and looking at some of the advancements that there are in Stable Diffusion training, they were able to conclude that at the max size of their training runs, they're not going to need 64 instances. They can get away with just 8. So first of all, cutting down the size of the cost by 8, just with that bit of research. The second thing that they said is that the way that you're doing your training, you're not going to need all of your instances at once. You're going to need to test the training. You can do that with one instance. You're going to need to test multi-node, test clustering. You can do that with 2 instances. And then you're going to need between 4 and ramping up to 8 instances as you run your training batches over time. So again, further cost optimizing by not needing all of the infrastructure all at once. We then said to them, have you looked at capacity blocks, which allows you to reserve your GPU capacity for a block of time and apply a discount? They would have further saved 60% versus the on-demand pricing. And then finally, we showed them that you don't actually need all to run everything on a P5. You can run some workloads, such as the image captioning, on smaller, more cost-effective instances such as G5. So as a result of that, we're able to help them bring their budget down from 10 million to 1 million. So I encourage you to reach out and talk to our team when you are doing these sorts of projects so we can help you cost optimize in a similar fashion. And finally, what I want to talk about is Bedrock Marketplace as a go-to-market for your model. One of the main things that startups ask myself, ask many members of our team, how can you help us get more customers? If you're building a model, this is a fantastic way because there is a journey to get your model onto our Bedrock Marketplace so that it shows up in the console so that the millions of monthly customers that we have who are using the console will be able to see that, click on it, deploy it into their own SageMaker environment, and pay you for the privilege. So if you're building models, you want to think about how do I optimize my training for inference using the right hardware, and then also how do I make sure that I can take that to market and use things like Marketplace to help really scale your customer acquisition and deploy to more customers. All right, thank you very much. I hope you found that useful. Enjoy the rest of the day.